Okay, the next second question, we have a question about transformation function. And the function that we have here is the trigonometric function. So y is equal to k sine 1 over 2x, and where k is a positive constant and x is measured in radians. Okay, the curve has a minimum point of a. So state the coordinate of a. So what we have here is only the information about the function itself, and that's it. Okay, so we have two types of transformation that we apply to the function, the original function of sine x. Now let's see what kind of graph that we will have for sine x. If we have sine x, we all know that we have, let's say we start at 0, and then we have the intersection with x-axis at pi here, and the other one here is at 2 pi. Okay, and our maximum value for 1, we know that for trigonometric function sine x and cos x, the maximum and minimum y value will always be 1 and negative 1. Okay, if it's the default function of sine x and cos x. And this one has a maximum value at pi over 2, because we measured this in radian, so we write as pi instead of degree. And this one is 3 pi over 2. Now let's sketch the graph here. So we will have this type of graph, okay? But the function that we will have here is k sine 1 over 2x. So what does k and 1 over 2 do to this function? So we have transformation, stretch transformation or enlargement. So if we have, let's say, k fx, what we will do to fx, and then f kx, okay, what will happen to the graph for this? So remember, fx itself is y. So if we times fx by k, in this case, k itself is here. So let me just change this to a, so it doesn't make any confusion. So a here is, we times the the y by a. Okay, so if we times y by a, we kind of make the y value higher. So y value becomes higher. Now, if we talk about graph, if we make the y value higher, for example, if I have, this is just a sketch, okay? So if we have the original graphs like this, if we times the fx by a, it will enlarge somehow in y-axis direction. So for this, we enlarge, I will use this, enlarge in y-axis direction with the factor of a. Now, what about fax? Now we look at this, the a here is applied next to the x, okay? If we talk about x, so the enlargement here will not be in y-axis, but it will be in x-axis direction. But the it will be in reverse relationship. So if we times by ax, okay, if we times by ax, now the original value of x itself will be decrease because we multiply by a, and then we want to have the same value of y. If we put a here, the x will be smaller. Okay, so for this we enlarge, or let's say we enlarge because we don't know the value of y, enlarge in x-axis. So because we don't know what is the value of a itself, so let's say we talk in enlargement here, we enlarge in x-axis direction with the factor of 1 over a. Remember, because if we put a here and f itself will give that one y value, okay, it will give one y value. To make the y value consistent, what you need to change here is the x. So x will be reduced if a is something greater than 1. Okay, so something like that. So for x, it is the reverse, in reverse relationship with the previous transformation, unlike the previous one. Okay, so let's see in this case. We have k here. K here is the transformation enlargement in y-axis direction. This one in x-axis direction. So now if we have this type of question, maybe you can start first with the one inside the function of sine, which is which is half x. Now let's see here. If we times the x by a, we enlarge the function in x-axis direction with the factor of 1 over a. So in this case, the a here is 1 over 2. A here is 1 over 2. So the enlargement here is higher, or it becomes larger than the previous one. It's stretched, not like compressed. So it becomes 1 over 2. So we enlarge twice in x-axis direction. Now, if you have, let's say, 2 here, not 1 over 2, if we have only 2, it will become smaller. Okay, since we have half here, so it becomes larger. So what you need to pay attention here is to the x coordinate. Now, we have the original coordinate for the intersection with x-axis is 0, 0 for this. And this one is pi, 0. This part is 2 pi, 0. Now, we enlarge the x twice, which that means we times the x by 2. So x only is this one. So 0 times 2 is 0. So 0 times 2 is 0. 0. We don't change the y. For pi, it's 2 pi 0. This one becomes 4 pi 0. We've multiplied x by x by 2. So we have this, we have the new part is this one, the new intersection point, 2 pi 0, and then the other one is 4 pi 0. Now, we also need to sketch the maximum and minimum point of sine half x. Let's see this one. The original coordinate before is pi over 2, 1. And the other one is 3 pi over 2, 1. Minus 1, I'm sorry. So this new coordinate after the transformation is 4 over 2 times 2, which is pi itself, 1. And for this becomes 3 pi, minus 1. So you will have here and here. Let's say this is 3 pi. Now you will have a new curve like this. Sorry for the bad drawing. Okay, this is the new curve of sine half x. Now we have k here. We still have k. I will use green now. Okay, we have k. Now, from this function, sine half x, I will rewrite again here. Okay. Okay, so this is the graph. So this is the curve for y is equal to sine half x. Now, if we want to put another transformation to sine half x, and then we put k here, that means we multiply the value by k. We multiply the previous y value by k. So what we will do here to this function is the transformation in y-axis direction. It's stretching in y-axis direction with the factor of k. Okay, since we don't know what is the value of k, that can make the y value smaller. It can become like this, or it actually can make the curve higher, like that. So let's say I will just sketch another one. So I will just sketch, we assume that it is actually higher. Well, we don't know the value of k. So it makes the maximum value from, let's say, since we have the intersection here is 0, of course, with the value of y is equal to 0. So if we times the y, let me write the coordinate again for this, is 0, 0, 2 pi, 0, and then this one is 4 pi, 0. If we times the y by k, this one by k, and then this one by k, it will not make any changes. So the intersection will stay like that. What will change here is the value above and below the x-axis. Okay, it's actually everything here will be multiplied by k. But since it's kind of impossible for us to do it one by one, so we can just focus on the maximum and minimum value. So from 1, this one is the maximum value that we have here is pi, 1, and this one is 3 pi minus 1. So if we multiply it by k, it becomes pi, k, and the minimum here is 3 pi minus k. So now if you look at this question is asking about a here, which is, this one is a. Okay, our minimum value, if we have this sine half x, k sine half x, is 3 pi minus k. We can also continue the curve to be like that. If we can continue like this, let's say I have, okay, since I only sketch one period of sine function, you can continue to the next part. Okay, now so the answer for this is 3 pi minus k. So for 2b, the question is, a sequence of transformations is applied to the curve in the following order. So the first transformation is translation to units in the negative y direction and reflection in the x-axis. Find the equation of the new curve and determine the coordinates of the point on the new curve corresponding to A. So we still have the same function. Okay, what we have here is k sine half x. Now, the first transformation here is 2 units in the negative y direction. So remember, if we talk about the y direction of translation, we kind of drag the function down into unit, because we have 2 units here, by the factor of 2, or by 2 units. Okay, so if we drag something, let's say we have a function of x here. Let's say I give another example, y is equal to x. If we put minus 2, we will drag this down. So the intersection with the And center here becomes here. So we kind of move it down 2 times. So we drag means we put -2. Okay, because we translate to units in negative y direction. The new function after the translation will be k sine half x minus 2. Okay, I will change this to blue for the first transformation, which is translation. Now, the second transformation is reflection in the x-axis. So if we talk about reflection in the x-axis, we can kind of treat the axis as a mirror. So if you want to treat the axis as a mirror, let's say we put, I will try to give another example as sine x. So if we want to reflect in x-axis, that means we flip and making the x-axis as the center of the reflection or the flipping process. Now, from this part, the upper part becomes the lower part, and the lower part becomes the upper part of the function. So what we change here, the x value stays the same, but y values have opposite signs as before. So we times all y values by -1. So it becomes minus of everything inside. It will be minus k sine half x plus 2. The next question is determine the coordinate of the point on the new curve corresponding to A. So what we want to find here is the value of A after the two transformations. Now, let's see. We have 3 pi. I will copy this one. Okay, we have this coordinate of A from the previous question. Now what we want to find here is the new coordinate of A after the two transformation. Remember, the first transformation here is translation to units downward or negative y direction, which that means only this minus k value that will be affected. It will be, after the first transformation, it becomes 3 pi. The x will not be affected. The y will be dragged down by the value of 2. So minus k subtracted by 2. Now, since we reflect in the x-axis, remember we only change the sign of the y coordinate. So from minus k minus 2, it becomes, again, the x is not affected here. It becomes negative of minus k minus 2, which is actually 3 pi and k plus 2. So the answer for the coordinate or the new coordinate of A after the two transformations is 3 pi comma k plus 2. And then the new equation of the curve is y equal to minus k sine half x plus 2.